Hi everyone, this is Soumyadi Paul, a mentor at CodeCardos and a software developer at Amazon. And I welcome all of you to day 23 of our DSA series. In the previous video, we saw how to do dry run in a recursive algorithm. And trust me, if you haven't watched that video, please do watch that video because dry running is the most important concept in recursion. Anytime you write a recursive algorithm and it is not working how you expect it to, if you do a good proper dry run with a pen and a piece of paper, there is absolutely zero chance that you will not be able to figure it out. If you do a good proper correct dry run, you will always 100% of the times be able to figure out what the error is. So now in today's video, we will be doing another interesting question, which is number of digits. Number of digits. So suppose you have been given a integer number. Say you have been given 3421. How many digits are there? There is this is the first digit, the second digit, third digit, fourth digit. So there are total 4 digits. And this is exactly what we have to do. We have to write a recursive algorithm that will do this. So we'll come here and try to write a code. So suppose I have a number int n is 3421, and then suppose I have a function and I'll call that function and I'll print it, say number of digits, and I'll pass here n. Okay. And here I'll have a dot. So this number of digits, now I need to implement it. Number of digits, it will take an n. Okay. Now, remember what exactly recursion is, the gist of recursion. The very first step is what? The very first step is to write a base case. And what is a base case? Base case is nothing but the smallest problem that I can solve by myself, isn't it? That is what base case is. So base case is the smallest problem that I can solve by myself. The smallest problem that I can solve for myself without recursion's help. Now obviously, for example, if this number is less than 10, suppose this whatever n is there, if this is less than 10, then I can be assured that my answer will be 1. Because with less than 10, and I am assuming that the input will only be natural numbers. Okay, input will only be natural numbers. So if n is less than 10, then n can either be 1, 2, 3, 4, up to 9, isn't it? And all of these possibilities have only one digit. So this is the base case, that if n is less than 10, then I don't need recursion's help. I myself can solve this. And I can directly say that, hey, the answer will be 1. Number of digits is 1. After this, after writing the base case, we will divide the entire problem into 2 parts. Okay. And how will we do that? Whenever we have something like this, say a number 3421, there are 2 ways to do this thing. Either I can divide it this way. This is something I'll solve. I'll find the number of digits in this portion, and this is something recursion will solve. Recursion will find the number of digits in this portion. Okay. This is something recursion will solve. So here what I'm doing is I'm breaking the entire problem into 2 parts such that the units digit is something I will solve and the remaining number is something recursion will solve. Another way is, I hope you guys have guessed it, is that if I break it in this manner, this is something I'll solve. And this is something recursion will solve. Okay. This is something recursion will solve. Now in both the way you can do this question, but we will be doing it in this manner because dividing a number into 2 parts such that the units digit is 1 part and the remaining number is 1 part is very, very simple. This portion can be got, suppose this entire thing is n, then this portion can be fetched or extracted by saying n by 10. And this portion can be fetched by saying this can be fetched by n modulus 10 and this can be fetched by saying n by 10. So for example, if your n is what? If your n is 3421, 3421, then if you do n modulus 10, you will get 1. If you do n by 10, you will get 342. So dividing in this manner is very, very simple, and that is why we will be choosing this manner. Okay. So this is what this becomes my smaller problem. This becomes my smaller problem. So what I'll say is int smaller problem is n modulus 10. Now the smaller answer, what will be the smaller answer? Whatever I do by getting n modulus 10, it will always be something less than 10. So the answer will always be 1. So here my smaller answer will be 1. And I've told this to you multiple times that whatever we write in the base case and whatever we write in the smaller answer is exactly same. The only difference is that in base case we return it, whereas in smaller answer we don't return it, we store it in a variable. Now bigger problem. What is the bigger problem? The bigger problem is n by 10. Okay, n by 10. This is the bigger problem. 342 is the bigger problem. And what will be the bigger answer? What will be the bigger answer? So the bigger answer becomes, I'll call a recursion. I'll call recursion and pass bigger problem to it. And I'll expect that recursion will somehow magically solve this and give me the answer. Once I've got both bigger answer and smaller answer, I can simply say int final answer is smaller answer plus bigger answer. That's it. And I can return it. Return final answer. Okay. Now if I run this code, hopefully it should print 4. Yes, it is printing 4 because 3421 has 4 digits. Suppose I say 1, 2, 3, 4, 5, 6, 7, 8. So it should print 8. Yes. Suppose I say 9,500 or 95,812. Then it should print 5. And yes, it is printing 5. Okay. So this is how you will solve for this question, which is number of digits. And please remember that this is what the gist of recursion is. You divide the entire problem into smaller problem and bigger problem. Smaller problem is something you solve and then store the answer in smaller answer. Bigger problem is something you pass on to recursion to solve. And then whatever recursion returns, you store that in a variable. And that becomes bigger answer. Then you somehow try to combine both smaller answer and bigger answer to get the final answer. Okay. So that's it for today's video, and I'll see you all in the next video. And if you want to learn these concepts in a much more in-depth manner and actually prepare for Mang-based companies or similar companies, similar top-notch product-based companies, and if you want to prepare directly from developers who themselves are working at Mang, just like me, then do join CodeCurdos.